Good morning, boys and girls, and happy Monday. This is Mr. Hamlin from Brant School, and I'll be leading our fourth grade science lessons this week. I hope everybody had a great weekend. I know last week we learned about different types of rock and what we could learn from rock layers with Miss Peters. And on Friday, it was a pretty interesting lesson when the Generation Genius people took us out to Sharktooth Hill, and we got to see how they were able to radiocarbon date the layer of fossils to find out exactly how long ago all that sea life lived out there in what looks like the desert now. So we learned that the fossils you find in an area can tell us a lot about what the environment used to look like. So this week we're going to expand on that a little bit with a couple things about rocks and fossils and how they can affect the earth. So let's get right into it. Today, instead of radiocarbon dating, which is a pretty complex science, we're going to be looking at relative age dating. And this is a vocabulary term right out of our Science Dimensions book that we'd be working on if we were back at the school. So relative age dating looks at the layers. So it's the sequence of events without exact dates, comparing one rock layer to the next. So they talked about that a little bit at Sharktooth Hill, and that we knew the stuff above the shark fossils was newer, and the stuff below them was older. So this is our vocabulary term for today, relative age dating. We're going to look at it a few different ways and see what we can learn from it. Another word here on the page for us is stratigraphy, and that's the name of the scientist that studies the rock layers. So we're going to jump right into our Science Dimensions book and take a look at a short video that explains this process of relative age dating and how we could use it.
This family drops old newspapers into a recycling bin. The bin is pretty big. Newspapers settle to the bottom as they're thrown in. It takes a long time for the bin to fill up. Pay attention to how the newspapers stack on top of one another. Which layer is the oldest? Which is the newest or youngest? The newest layer of newspaper is on the top.
So, very similar to what we talked about last week when she had the topsoil being on the top, that newest level. We see something very similar with the newspapers here. So hopefully that visual was able to bring it all together for everybody. So with the Sharktooth Hill video, we learned how the fossils that we find can tell us a lot about what the environment had been like at different times, where we saw there must have been water there before for them to find whales and sharks and turtles. So today we're going to take a look at another video that also shows us how just what the actual rock is made of gives us a lot of indication about the environment from long ago. So let's jump back into our presentation here and take a look at the monument rocks of Kansas.
In western Kansas, a series of spectacular shapes burst up out of the plains. They're called monument rocks, and the raw material for these towering structures was formed more than 80 million years ago by the smallest of creatures. This place is amazing. I've been looking for just a few minutes, and here's a shell. It's an oyster shell. I've been finding these things all over the place. And this whole place is made of shells. There's really big ones, there's small ones, even the chalk itself is made of microscopic. So why are there shells here? Answer: Kansas used to be covered by a massive inland sea. Over time, the giant oysters living on the seafloor were buried by billions of tiny plankton shells as they died and fell to the bottom of the sea. Layer after layer. Over millions of years, all that weight compressed them into chalk. When the sea finally drained, that chalk got left behind. Millions of years of erosion sculpted the chalk, leaving behind these curious outcrops that now surge skyward out of Kansas.
All right. So for today's assignments, when we're all finished with the video, you're going to open up the Google form that's in your Google Classroom, and it's only got 2 questions on it for today, and we're going to be discussing relative age. So you're going to use the 2 short videos that we looked at today, the one with the recycling program and the newspapers, and the one that we just watched about those monument rocks out in Kansas and how they formed. And we're going to compare and contrast the 2 videos, how relative age was demonstrated similarly in the both of them, and how it would be used a little differently when we're talking about newspapers versus rock formations. So that's only going to be about a paragraph. And again, both of our questions today are on the one Google form. So 1 paragraph comparing the relative age of newspapers and the rock formations. And the second question, I think, is a little bit fun. We're going to look at the M in STEM today, and we're going to do the math. So here you've got some data about the relative age of different layers of rock in a rock formation. You're going to use this data below to try to arrange these layers from youngest to oldest. So you might want to lay this out on a piece of paper, find the ones that you know that you can put in line with each other relative to each other, and then fill in the other layers as you go. So there's 5 layers, and on your Google form, they're listed in several different variations, and you'll have to pick the one that you've worked out to be the correct order from youngest to oldest. So just 2 things you're going to work on today, that 1 paragraph up on the top of the form, where you're going to compare and contrast the newspapers and the rock formations discussing relative age, and then you're going to do some math and put these rock layers in order by taking a look at the data on the screen. So I hope everybody enjoyed today's activities about relative age, and I'll be back and see everybody again on Wednesday. Thank you, boys and girls. If there's any questions, just get them in your Google Classrooms for your teachers. Have a great day.